Hello, everyone. Thank you for joining. My name is Robert Munteanu. This is Resource Resolution and Mapping. Fun and simple. Now, a couple of words about myself. I work for Adobe in Basel, Switzerland, although I'm originally from Romania. I work on AM as a cloud service, and I'm serving as the current PMC chair of Apache Sling. Member of the Apache Software Foundation, also involved in the Jackrabbit and Felix communities. Now, today we're going to be talking about resolution and mapping, and we're going to start off with the basics and say, what does resolution mean? What does mapping mean? Where are they used? What are the use cases for these operations? Then we're going to see how to influence the results of resource resolution and mapping. We're going to have a demo about the mechanisms that we discussed, and wrap up with some non-functional considerations, performance and security, as both of them are sometimes a bit easy to overlook and can lead to surprises. Now, basics of resolution and mapping. So the resolution is an operation that is usually done implicitly for you by the Sling engine. So it takes a request or sometimes just a resource or just a path and returns a resource. It's basically one of the core principles of Sling. When we have a request, how do we decide which resource is being used to render it? You usually don't need to worry about that. The Sling engine does it implicitly for you. But if you really want to do it yourself, there's an API on the resource resolver that is called, well, surprisingly, resolve, and takes a request and gives you a resource. It never returns null, so you need to be careful to check for a non-existing resource. And one very important part where it is used is an URL decomposition, which means, okay, we have a resource, a request, let's find the resource. And sometimes it is very plain and simple, like when you have this content welcome.html. So probably it's the resource is content/welcome, and HTML is the extension. Sometimes it gets a bit more complicated. And one good rule to remember is that you probably can make guesses about the resource path by looking at the request, but only by looking at the repository. And Sling has a very well-defined algorithm. You can understand which one the resource path is, and which are extensions, selectors, suffixes. There's nothing stopping you from having a resource called /content/welcome.home. So you cannot judge that just by looking at the request. And this is where the resource resolver resolve method comes in. Now, mapping is designed to be the exact opposite of the resolve operation. No, it takes a resource and says, what is the URL for it? And usually, I think it's invoked a bit more often from user code compared to the resolve operation. And you do it when you want to have canonical paths for a URL reference. So which URL should I use to generate this link, or for displaying this image or this media file? It's also of use when you're trying to find out which path should be authenticated when you have a resource and you want to make sure that it's authenticated under all the alternate names. And something to watch out for is that the result is %encoded. So you cannot just do this mapping in a loop or successively and expect to get relevant results. You almost always need to do it on raw paths. And there is the resource resolver map, a method that takes a request in the path and gives you the canonical mapping. And then there is a new API called the ResourceMapper, which you obtained from a resource resolver, and you get all the mappings. But that's, again, for special circumstances, you probably don't need it. I mean, the only consumer that I'm aware of is the Sling authentication core module, which is used to take care that everything is properly protected by authentication requirements. Now, sometimes it can be a bit challenging to understand what is going on in the resolution mapping part. So the Sling console the web console resource resolver page is a very good entry point to understand what is going on. So you have both a listing of map entries and resolve entries, and you'll get the full listing in that page, so you can understand which patterns are applied. And then you also have an interactive part, which allows you to simulate map and resolve calls. And yeah, that basically means you get to simulate without going to a full request response rendering cycle. And so I said, resource resolution, simple and fun. That was the simple part, which is not necessarily fun. And we're going to the fun part, which is not necessarily simple. In Sling, there's more than one way to do it when it comes to influencing resource resolution and mapping. So we're going to take a very, let's say, broad view of what is possible without necessarily doing a very deep dive into each of the mechanisms. So the first one is OSGI configuration. The resource resolver factory is able to configure these a couple of properties. One is virtual URLs and another is URL mappings. The difference is that virtual URLs are for full paths only, while mappings apply to fragments as well. So you can definitely do most of the things that you do with other mechanisms inherent in OSGI config. I don't think that's particularly a very good idea, since it's one OSGI configuration. So it means you can only have one place. You cannot have multiple components contributing to those mappings. And usually OSGI configs, especially in the cloud service context, but not only, are better regarded as immutable, because whenever an OSGI configuration changes, there can be a cascade effect. Components unregistering, being reconfigured, being re-registered, and especially the resource resolver factory is quite sensitive. There are a lot of change dependencies to it. So probably these are very well suited to just a few static calls that will always happen, like the one that says /content is going to be mapped to the root. The other options are all based in the repository, which is has a life cycle which, in my opinion, is better suited to editing this, to influencing the resolution and mapping. And the simplest mechanism is an alias. And an alias is an alternate name for a resource. And you define it by setting a special property called Sling alias on the resource. And here we have an example of content welcome. And we give it a couple of aliases of willkommen with 2 L's, actually not one, sorry, my bad, and bun venit, which is the same thing, but in Romanian. And what happens is that if we want to load these resources, they render exactly the same. So internally, the resource path is switched in Sling, but it doesn't generate redirects or influence the rendering output in another way. Just renders exactly the same. Now, vanity paths are the, let's say, an enhancement or an upscaling of the Sling aliases that comes with a couple of pitfalls. So whereas a Sling alias has an alternate name, a vanity path is an alternate path for resources. And in the same way that you set a Sling alias property on the resource, you can set a Sling vanity path. But instead of making sure they have the same parent, the vanity path can appear anywhere in the repository. So in this example, we have a contentful bar as a resource that can be accessed as /welcome or /nested path here as well, which is indeed a very powerful mechanism, but it can lead to unpredictable results. And by that, I mean that it is a bit hard to visualize how your path structure is going to look like once you start becoming very liberal with creating these vanity paths. And it can create troubles in authentication. I'll get to that a bit later. But indeed, I'll say that vanity paths really are a powerful mechanism with great power comes great responsibility and all that, and they should be used sparingly. Now, aliases and vanity paths are properties set on a resource. There is a different mechanism, the mapping entries, which are based on a completely different subtree in the repository. So we get a resource tree under @cmap by default. It is configurable, but it is one of those things which are configurable, but you really shouldn't change the default because it's going to confuse everyone and everything. And under that @cmap structure, we try to create a nested tree structure that will match incoming requests. And you see here the canonical way of representing it, which is scheme/server name .server port /path/info, and then you can get multiple child entries. So for instance, a request to sling-apache.org/content will be converted to this one, http://sling.apache.org.80/content. And to see that, we will have the following representation in the repository. So it's a very nice way, in my opinion, to map requests to the hierarchical nature of the Sling resource tree. And there are a couple of ways to get creative. So when you have a node for a host name, for instance, you are confined to what JCR and the Sling resource tree consider a valid node name. And the nice part about these entries is that they are all regular expressions. But of course, not all of the regular expressions are valid JCR node names. So Sling offers you this Sling color match property, which is a way of replacing the value that is matched by the node name. So in here, we say take this local host any, which is not a naming convention. It's just a naming convention. It doesn't mean that Sling assigns any valid value to underscore any. By the way, set the Sling match property that it matches localhost at any port. And then this gets inherited down the line. So the content node matches localhost on any port and then /content. And we can use this to modularize our mapping entries. So if we have an application that we want to have deployed without any conflicts in a Sling-based application, we can give the host name matcher any name, and then we say this is localhost on any port. Okay, which works fine when you're deploying on localhost, but probably you want to have it matched on different port, right? Unless you're doing a very specific form of port forwarding without any virtual hosting, name-based virtual hosting. So the resource resolution bundle, the resource resolver bundle allows you to have externalized values for matches. So you take this same Sling match property and instead use placeholders. And that comes straight from the resource resolver bundle, no external dependencies. And you can use environment variables, which are widely used when you're doing container-based deployments, or bundle context properties or OSJ configuration. And you can use it for at least two purposes. One is to do this kind of modularized deployment. And two is to have a immutable definition of mapping entries and deploy them through dev, stage, and prod successively without changing anything except for setting this local host name part. Now, okay, we've talked enough about the base and the host name resolution part. Let's see what actual redirects, how we can actually influence the resolution rules. So a very simple way of doing that is setting the Sling redirect property on a node. And in our scenario, we can redirect from Nachrichten to news. And that simply, it looks a lot like a Sling alias, only that this one generates an HTTP redirect. However, we can also do internal redirects, which again, now this really looks like a Sling alias because it just replaces the current path internally during resolution. And when you're doing external redirects, you can also influence the HTTP response code that is that's being sent, whether it's a permanent redirect or a temporary redirect or something else that you want to use. Now, you can also use regular expressions for matching. And this, again, is a bit powerful. So in this example, we say that for everything that comes after links.example.com, we capture it, and we use the regular expression capture group reference in the Sling redirect property. These kind of redirects are, so resolution map entries are used for both resolve and mapping. So there are two-way mappings. When using wildcards, they don't always work for reverse mappings. So they work in certain limited cases when you're using internal redirects. So if you want to use regular expressions, you should check whether the reverse mapping also works. And yeah, if you need it, obviously. Okay, good. That was a lot of talk. Let me change the sharing setup a bit, and I will take you through the demo. Okay, now, okay, so we have here the console, and let's bring up, right, let's refresh. It's probably, yeah, I guess everyone knows the username and password. So, all right, I will make this a bit bigger. So first of all, we have this content tree, and we have this remade, which is a proprietary of an acronym from resolution and mapping demo. And we have a couple of pages here. So first of all, we have this welcome page, which has a couple of Sling aliases set. All right. And first of all, if I go to access remade.welcome.html, I get, I think text is better rendered here. I get the resource rendered by Sling. And one thing I want to point out is that the path is /remade/welcome, but the resource path is actually /content/remade/welcome. And that is a side effect of how the, well, is not a side effect, but an effect of the default OSGI configuration of the resource resolver factory, because it is able to append /content to a request in doing resource lookup. And you can also see that we have these Sling aliases. So let's, if I request this welcome on resource, which does not actually exist in the tree under content remade, it gets rendered. And we see that this is the original content remade welcome resource. So that is what I mean when I'm saying that it is replacing the resource path internally. And of course, the second vanity path, the second alias will work the same. So there is no need into looking into this. Now we have another page which has a Sling vanity path. And if I access that vanity page, it is, of course, the page that we were looking for, right? I can also render this, the target of the vanity path, which is a totally invented page. And it works as expected. Again, nothing is present in the repository. and it is rendering that the page from here, although it's accessed using this way. Now let's dive into AdCMap as well. So we have this remade data is using the Sling match property to say this is basically localhost any, right? The resource name from here is not being taken into account. And we have this WLC, which is, in my mind, short for welcome, and is doing an internal redirect to welcome.html. So let's see how that works. Sorry, I meant, okay. And the resource path is the one that this is pointing to content remade welcome, right? We make a direct redirect to welcome.html. We can have nested redirects. So if we do this short URL, which makes no sense, but then again, in my opinion, most of them don't. Oh, sorry. No, I did something wrong here. Right. It generates an. Sorry, let's do that again. So it generates an 302 redirect to sling.apache.org. And that is the way we have instructed it to work. Another option is to match on the node name with extension, right? The previous redirects were using a raw name. So if we want to redirect to this promo.html page, it is again working. And something I want to show here. So we have this node name, which is not being used in resolution because the Sling match is being used. It defines promo.html. And the Sling redirect is made to the content remade nested page HTML. But the location is actually the other content appended. So it is useful to think of these rules as being nested and operating on top of each other, because the redirect has been also processed. Now, this is an example of a regular expression redirect. So everything that comes after out is going to be redirected to example.com. So you can see here that the redirect has captured whatever I was appending after /out without needing to specify a number of redirects. And of course, we can do all sorts of name-based virtual hosting setups. So we can define a hostname of sling.apache.org.at and then set up a internal redirect from documentation to docs. All right, that wraps out the presentation. The demo part. Let me go back to my demo and resume. So I think no, this is here. Okay, I hope this is still visible. Okay, great. So I mentioned the non-functional considerations that sometimes can get tricky, especially in large projects. First off, it's performance. Now, aliases, especially aliases and vanity paths, are things which can accumulate to large values, and it starts to become tricky from a performance point of view. And these are usually processed using JCR queries. We do a query at startup and see, okay, what vanity paths do we have defined? And we build them into a structure called a Bloom filter, which is then persisted on disk. So we have sort of a persistent cache And a Bloom filter is described as a probabilistic data structure, which means that if we find a hit in the Bloom filter, there could be something, a vanity path defined, but if we don't find a hit, then we definitely do not have a match. So we use this for performance, but again, it's something that needs to be persisted on disk, updated. It's a trade-off of startup versus runtime performance. Aliases are also queried at startup. There's a query that runs all over the repository to look for aliases to build a cache data structure. And yeah, those can add up in time. There are various things that can be done to make sure that the performance, the interactive and the startup performance are still good. One of them is that we have stopped querying the whole repository in recent versions of Sling. One notably bad place to look for aliases and vanity paths into was JCR system. And not only because there were no entries, but because there actually were entries in the version storage. So if you're using versions for your content, like AM does for pages, for instance, you would activate pages, and if those pages had vanity paths and aliases, those would get saved under JCR system version storage. And at startup, when Sling would be coming up, they would be found by the query and then discarded. So that's one reason to update to recent versions of the resource resolver. And then we have this option to configure allowed paths for vanity paths and aliases. So the queries can now be scoped to certain subtrees. For instance, if you know that you only have them under /content or even a certain subpath of /content, you can query those, you can configure those for both querying and observation. And that will ensure that you have good startup performance of your resource resolver components. And lastly, but last of all, but not the least important, is security. So we have in Sling, we have the concept of access control entries that are defined by the JCR repository, and also the concept of authentication requirements, which are reflected, for instance, in AM by using the closed user group functionality. And these authentication requirements are also hierarchical. And when you have a protected page and you have it available under alternative paths, whether it's aliases or vanity paths or mapping entries, the Sling authentication core bundle makes sure to register all its alternate names or paths as being protected. And there's still one edge case where this doesn't happen, and it's a bit complicated because it is an edge case, but still, if you have a parent page that is being protected and a child page that has a vanity path defined that is not under the parent page, so it basically escapes the resource tree, then an authentication requirement will not be correctly registered for it. So again, leading the discussion into the idea that vanity paths are powerful but tricky. So if that's one of your use cases, you should review your authentication setup and double check that you're not leaking anything. And that basically wraps up my presentation. The first and best recommendation I can point you to is the Sling page about mappings for resource resolution. It's a reference page. It's quite comprehensive, and you probably get answers to most of your questions from there. If not, feel free to ask on the Sling users mailing list. We'll do our best to get an answer to you. Okay, so I guess I can stop sharing somehow if I can find the right buttons. And let me look at a Q&A tab. So I think let's take them in order. Viewers, how does this scale? Say, if I want to use Sling mappings to set up one key Sling redirect rules, can it impact for performance? So I don't have a very clear answer here. So yes, it can impact performance. Depends on your hardware and on your targets. I'd say 1K is not necessarily in the range we'd consider a lot. We have this rule of the thumb that 10K is a lot. Whether that holds in practice for you with your current hardware and your current needs, I can't say. So you should measure, but I wouldn't be too worried about 1,000 redirect entries. So next question, how would you take care of resource resolution if the same alias or vanity URL is used for other pages in the content tree? So I'm not sure I understand. So if the same alias or vanity URL, so there are two cases which I think can happen is like an alias shadows a page, or an alias or a vanity URL overlap. And I would say it's undefined behavior. If you're doing that, you're a bit on your own if you have these kinds of clashes. So to your question about a security issue is that issue. So it is not related to access control entries. So if you let's take Compose, right? It's a repository browser, and it's available at /bin/browser. And by default, this is accessible to everyone. But probably you do not want to expose this repository browser feature to everyone. So you would install an authentication requirement for /bin/browser. Now, at the same time, if you install a vanity path, well, that's not a very good example because bin browser is a virtual URL, but still, right? If you install a vanity path for such a resource, then it will be the resource you wanted protected by an authentication requirement would actually be accessible without it. And basically what the authentication requirement does is forces users to log in. This would not circumvent the access control entries from the repository. So one more question, is anyone aware if the Sling resource resolver is now capable of mapping the paths returning by resource get path correctly? So I personally would have to look into it into more detail. I don't even, maybe Sling 8851 is related to the refactoring we did so that the resource resolver exposes all the alternate mappings, and that the authentication core bundle installs authentication requirements for each of them. We have had, so since we did that refactor, we had a couple of iterations on fixing some edge cases related to mappings. So it is possible that it is solved. If it's not already reported as an issue and it's still not fixed in the latest version of the resource resolver bundle, yeah, please file a bug and we'll look into it. So I guess that is the final question that we had. So with that, thank you very much for your time, and enjoy the rest of the conference.